Okay, today's video we're going to have a look at ADAS calibration. So some of the different systems that we see within ADAS and how they're calibrated. So Christian, we've got some different systems here that we're seeing today.
Absolutely.
Maybe you could just give us a quick rundown on what they are and what system are they and what we need to do to calibrate those.
Absolutely. Hello from my side as well. Great to be here. So like Daniel said before, we will gonna start and show you now the most important components of the ADAS system and how to do the calibration. We start directly here on the right hand side. This is the so-called active lane assist. The active lane assist works with the front camera. Daniel is showing that to us. So it's a front camera which is installed into the windshield. Yeah, and this is recording the street basically. It needs to be calibrated. Then let's move on. Here in the middle is actually not a real ADAS system, but it's a supporting function for different ADAS systems. We're speaking here of the LiDAR. And the LiDAR needs as well to be calibrated in order to record the street correctly. And for what system? The LiDAR could be a big support or a big help. For example, for adaptive cruise control, for the ACC system. So what do we have here? Instead of a camera or LiDAR system, we have a real radar which is detecting the street way in front of the car.
So obviously the vehicle is interpreting the signals that it would see from these systems. So whether it's the radar, whether it's the LiDAR or the camera, it's expecting whether it sees a vehicle in front or a person, that it's going to be in a certain parameter. So obviously if the calibration is out, it's
out of range?
It's going to interpret those signals incorrectly.
Absolutely.
So it might cause some accidents and things like that.
Absolutely. In the best case, the system doesn't work anymore. In the worst case, the system thinks it is still working, but detects, for example, the wrong side, or instead of the street, the sky, or whatever. So it is absolutely important to do the calibration.
And that's what we've seen in reality quite often, is brackets being bent, holding radars.
Yeah.
Things like the cameras and LiDARs are often in the windshields. And we're seeing when windshields have been installed incorrectly, or sometimes using
the wrong windshields.
The wrong windshields, or even aftermarket windshields as opposed to genuine, even that alone causes some problems.
Absolutely. So you find all this information in the e-learning course as well. Exactly what you said right now, it's all in the course.
And we will be making more and more videos that go into the detail of each of these systems.
Absolutely.
But what we're also showing is some of the things that, how these systems are being calibrated, so that when a technician installs a new windscreen and it doesn't work, it gives them some idea of what needs to be done in order to get the system repairing again.
An important point here to add is that we designed the calibration process here on the one hand, like on the real car, but we have added a few more things which will be normally automatically done by the diagnostic tester. But our goal here is to give the student the best understanding. He should know and understand what the automatic system is doing while the calibration process. This is why the student becomes the diagnostic tester in that case.
So if we switch to our software now and have a look at this system here, the camera-based system, so we can see this is within our e-learning software, and it's giving you an idea. This is the interface of the lane assistance
Absolutely.
system.
This is basically our calibration diagnostic tool, what we have opened here. You see it here from the driver positioning and what the camera is seeing. And of course, we have a very nice view on the lane, and in that case, the system works pretty well. So in order to achieve that situation, that it works pretty well, we need to do the calibration.
Of course, and you can see here on the screen, the system is really looking for those white lines. You can see how the white lines are a little bit more highlighted within the picture there. And when the system does go over the white lines, it brings up the red warning. And so that's giving you an idea of the key features required from this system.
Absolutely. So I would say just let's jump to the calibration. And this is perfect for this system, how easy you can do it here. So we have the setup basically, you have shown that before, and now we jump to the calibration system.
So this is the camera in front of the calibration target here.
We can zoom out. So this is what normally the system or the automatic diagnostic tester would do automatically. And like Daniel said, we see now our calibration target, which is the same target which is used in the workshop, just much smaller.
So one of the advantages here is in the workshop or at the college, wherever you're training this, obviously you need the vehicles that have these systems on board. And so this is a way to make it a little bit more accessible to more people to understand how the calibration is done.
Absolutely. And this is exactly, each student can do that on his desktop. And as I said before, we have done a lot of functions manually, which you normally, or where the system normally would run through automatically. So one very important point is the recognition of the light. So how much light is going into the camera. And as you see here, nothing is simulated, that's all in real time. But we have right now a problem that the camera cannot interpret exactly. So Daniel is moving in there. There you see it can't really understand the picture because there's too less light. So what we have to do now, we have to increase the light or the sensitivity which comes into the camera. And there we see now suddenly how it detects the calibration target now in the filter as well. And now what we have to do basically, this is what the system would do automatically too. We have now to put the rectangle into the white box. And this is exactly what we do here. So now we have to zoom in a little bit. There you see. So this would normally work completely automatically. Here we go. So, and there we see now we are calibrated. So this is basically what has happened now. The camera has now saved that, still depending on the light a little bit, but the camera has now saved these adjustments regarding the different angles inside the camera.
So once it's calibrated, then that would be saved and it's ready to go.
Absolutely. Then you are ready to go back on the street. You will get the protocol and everything is fine.
Okay. So the next system that we see here, LiDAR, is using a different type of calibration target.
That's completely different because we are using here a light depending system.
Okay.
So this is about, this system recognizes the reflection or not reflection of the laser light which is sending out.
Okay. So there's a different type of interface that we would use here as well?
Absolutely. So we directly jump here into our LiDAR monitor. And as we see here, we see the clear front of the LiDAR of the car.
And you can't see that very well from the camera where the camera is right now, but this is an actual LiDAR unit that's spinning around and it's giving out. Here we've got it to, I think, 130 degree angle.
Exactly.
We can also set it to a 360 degree angle to see everything that's around
there. Then we are close to the Google car. Okay, what we see here now, it's basically like you put your hand in front of the camera. We can do the same here with the LiDAR. It's a real-time measurement and it directly detects my hand here. Right after, or Daniel's hand of course, it's a little bit bigger. Right after our hands is the calibration target. This is what you see basically here with this gap. And now when we have a look at the calibration target here, there we see that we have three different gaps. At the lowest point, we have a small gap. In the middle, we have the widest gap. And above, we have a little bit smaller gap. So our aim is now to get directly in the middle. That means to the widest gap. And what we are doing here, this is now not automatically done. This is done by manually adjusting the screw.
So this would be the mounting brackets you find on the vehicle. They would have some sort of adjustment possible that allows you to define the angle. So
now we are at a higher point. I'm a little bit too high, so I have to go a little bit deeper again. And there we see now, we have now the wide gap in here. And when we are at this level, then the LiDAR is, straightened up correctly, or the angle is correctly of the LiDAR, how it sees the street. So another way of calibration, basically.
Okay. All right. So the third system that we'll have a look at is the radar system. So
Exactly.
very common as well. It's been around for a little bit longer now. Adaptive cruise control. So obviously being able to adjust the speed of the vehicle depending on the traffic in front. So radar, now we can see the radar on the system here as well.
Absolutely.
But on this target, we're using the lower target within the calibration table that we're seeing here.
This is absolutely true. So this always comes together as one unit basically, but now we need the coordination system down there, and we're doing the calibration here as well for the radar. So we're going into the sensor details, going to sensor calibration. There we have to adjust the distance, how far the calibration target is away. We have done that here, and then basically the next thing is there are different ways. In that way, we do it automatically as well. So what we can do here now, we can activate the laser system basically.
So the laser is in the radar, or is it?
The laser comes from the starting point here at the coordination system and goes to a mirror at the radar and is reflected back to the coordination system. And there each manufacturer tells you where the light dot has to stay in order to be calibrated correctly. So it's not like that it has to be at 0, 0. That just is up to the car manufacturer. There you see. And basically, okay, we are very much calibrated here because we have to go to -1, -1. And we can improve that as well with our screw here as well and move the single screws over here. So when we now change these screws here, we are able to adjust the position of the red dot, but like I said, it should stay at -1, -1, so we are here fully calibrated already.
Okay, thanks Christian. So that gives you some idea on the common calibration systems that you see within the workshop.
Absolutely.
And just some of the ways that we've reinterpreted that just to make it a little bit more understanding.
Absolutely, and just give us a feedback where you want to go into more details, so we are absolutely up to do more of these videos and go up in more certain details. Also, if you have more wishes regarding hybrid electric vehicles, basically, yeah, we will focus on the ADAS system and on the hybrid electric vehicles, and just let us know your wishes and we will dig ourselves into the topic and give you explanation by video.